Okay, so now we will talk about the basics of enzymology, that is the structure and composition of enzyme. So I have already made a video. I will pin it in the comment description. Okay, about the what is enzyme, who coined the term enzyme. Okay, and what is holoenzyme, what is apoenzyme. Okay, now let's talk about them one by one. So the enzyme consists of the following part. Okay, it consists of the apoenzymes. Okay, it has the active site also. It has the prosthetic group, and it has coenzymes or cofactors. Okay, so now let's understand them one by one. What is apoenzyme? So apoenzyme is the protein part. Okay, we have to remember this. And the next thing about the apoenzyme is that it is the major portion of the enzyme. Okay, when we are talking about the enzyme structure, it holds the major portion. Okay, now we know that different enzyme, they will possess different sequence of amino acid. Okay, and the length of the protein molecule also vary. Okay, the specific sequence of the amino acid in the protein molecule, it will only lead to the specific nature of enzyme. Okay, so the sequence of the amino acid in a protein is crucial for determining its activity. Okay, so the protein, they are colloidal in nature. Okay, they will, okay, so they will provide a very large surface area per unit of volume. Okay, and there are only few enzymes that are entirely made of protein. Okay, and these enzymes, they are known as simple enzymes, like example urease, amylase, pepsin, etc. Right? So but most of the enzymes, okay, they fall into the category of conjugated enzyme. Okay, the conjugated enzyme composition include these. Okay, so now let's talk about the second component, that is the active site. So the active site is also known as the active center. Okay, so we know that the enzyme, it will catalyze the reaction. How it will catalyze the reaction? It will, the enzyme, it will get combined with the substrate. Okay, it will act on certain substances known as substrate. Okay, so the substrate, it will physically comes in contact with the specific site in a protein molecule. Okay, the surface of the folded protein possesses specific binding site known as active site. So suppose this is an enzyme, so it will have a particular space, okay, for binding of the substrate. So this space, okay, is known as active site. So it is the site, this is the enzyme where the substrate will come and fit. Okay, so we can also say that substrate binding site. Okay, now the interesting thing about the enzyme is that certain enzyme, they will have only single active site. Okay, but there are few enzyme also that has several such sites. Okay, so the enzyme, they can have single or multiple active site where the substrate can bind. Okay, the substrate binding site is termed as the active site, while the regulatory substances, they are bind within the regulatory sites. Okay, so for the enzyme, there are some regulatory factors also, regulatory substances, so they will bind to another sites. Those sites are known as regulatory site. This site is specific for the substrate binding only. Okay, so next we will composition of the enzyme is the prosthetic group. So I told you that most of the conjugated enzyme, they will need the non-protein part. Okay. And why they need the non-protein part? They need it for their efficient performance. Okay. So the non-protein part will tightly bound to the enzyme. Okay. So this is the enzyme. Okay. This is the active site. This is the active site. Okay. Now it has some space also. So there are non-protein part. This is the non-protein part. This non-protein part, okay, when it get attached to the enzyme, then it is known as holozyme, okay, or complete enzyme. Or the complete enzyme. Now this non-protein part, when it is attached to the enzyme, then it is known as prosthetic group. Okay. Now then what are this prosthetic group? So the simple prosthetic group includes the metallic ions. Okay. So the prosthetic groups are basically the metallic ions. Okay, such as copper, zinc, manganese, etc. Okay. And there are in addition to these metallic ions, there are certain other categories of the prosthetic groups also. These will include cytochromes, flavoproteins, heme iron, etc. There are several. Okay. Now, the very fascinating thing about these prosthetic group is that they are associated with the active site of the enzyme molecules, okay, and in some cases they will also undergo the prosthetic group, they will also undergo reversible chemical change. Okay, this is the point to be remember about them. Now next, the fourth one is the coenzyme and the cofactor. Okay, so now in the science there is no clear-cut distinction between the prosthetic group and the coenzyme. Okay, so it is conveniently defined that the prosthetic groups, they are tightly bound to the enzyme, whereas when they are not attached or they are loosely attached, they are known as coenzyme. Since these are like these substances, they will affect the overall reaction, they are known as cofactors or the coenzymes. Okay, so the term cofactor, it was usually employed for the inorganic ions. Okay, so they are very important for the activity. Okay, so they are basically the inorganic ions. Okay, like calcium, like chloride, magnesium. Okay, and these are essential for the activities of enzyme. So some of the coenzymes are like hydrogen carriers, like NAD, that is the nicotinamide adenine dinucleotides. Okay, then there are NADPs, that is the nicotinamide adenine dinucleotide phosphate. Then there are some flaming nucleotides, thicotic acids, ascorbic acid, ubiquitinone, glutathione. Okay, then there are some acyl group carriers, there are amino group carriers, biotin, thiamine, pyrophosphate, folic acid, etc. Okay, so before closing this video, I will just give you the difference between the coenzyme and the cofactor. The coenzymes, they are the organic compounds. Okay, so the coenzyme, they are basically organic compounds. Okay, that are not lightly bound to the protein part of the enzyme. Okay, and usually they will act as a donor or the acceptor of the atoms, okay, that are added to or removed from the substrate. Okay, so these are the example. Okay, these carriers are the example. But when we are talking about the cofactors, then these cofactors are the inorganic ions. Okay, they can be metallic or the non-metallic. They are linked to the protein portion of the enzyme by either by the electrostatic bond or the coordinate bonds. Okay, they can be easily removed from the enzyme by suitable treatment. Okay, the enzyme do not perform its catalytic function in the absence of these activating ions. For example, there are certain inorganic elements like potassium, magnesium, calcium, manganese, chlorides, etc. Okay, so these cofactors earlier, they were also known as metal activators. Okay, so I hope this is clear to you. I will keep the video short, okay, so that it is easier for you to understand step by step. Thank you for watching the video.